Hello everybody, welcome to the module of predictive analytics. Today's topic is neural networks and deep learning continued. Our session information will be having basic focus on installation of PyTorch, CUDA toolkit and cuDNN. We will be installing CUDA toolkit, cuDNN and PyTorch in this tutorial before we embark into implementation of CNNs. In the last video, you saw implementation of a basic two layers of neural network using NumPy. In this tutorial and the upcoming ones, you will see how easy it is in implementing CNNs using PyTorch. Now let's go into CUDA toolkit installation. Let's start. First we'll install CUDA toolkit, for which go to the site https developersnvidia.com CUDA zone. Now click downloads, download CUDA toolkit. Here you click at the download button. Go to legacy releases. Now download CUDA toolkit 9.1 version. Select OS as Windows, version as 10 or whatever Windows you are using. Installer type as exe network. We are using Windows for this tutorial. If you are using other configurations, you can appropriately select the options and download the toolkit. You can see the download is going on. In a minute it gets downloaded. Click yes, then OK. CUDA setup is complete. You can see CUDA version 9.1. Checking the system compatibility. Wait till it gets completed. For CNNs, Nvidia installer is recommended. Wait till the system check is over. Now click agree and continue. Then you'll find a dialog box where Express is recommended. Then next. You can see preparing for installation. It will take few minutes. Once CUDA gets installed, next we'll be moving to cuDNN. These toolkits are mandatory for implementation of CNNs. You have to wait till the process gets completed. You will find download in progress In the meantime, let's move on to the installation of QDNN. Go to https developer.nvidia.com QDNN. Here click download QDNN. Next comes terms and condition. Here click I agree. Then click archived QDNN releases. Next, download QDNN version 7.0.5 for CUDA 9.1. Then select Windows 10. You can see it's getting zipped and downloaded. Parallelly, you can check CUDA toolkit is getting downloaded. It's showing 10% complete. In the meanwhile, we can install PyTorch. Go to https pytorch.org. You can find here, and you can check here, select OS as Windows, package manager as pip, Python 3.6, CUDA 9.1. We are using Windows for this tutorial. If you are using other configurations, you can appropriately select the options and download the toolkit. Now open CMD and type the command pip install http download pytorch.org. WH1 Q91 torch 0.4.0 CP36 CP36M. win AMD 64 L. Requirement already satisfied. Torch 4.0 given the address. Then type pip install torch vision. It will collect the torch vision. Installing collected packages numpy torch vision. Meanwhile, we can check download is in progress, which is 24% complete in Nvidia installer. We can check QDNN, extract, into C drive, program files, x86, click OK. Yes. Extraction is in progress. Now for numpy, if you are using Linux or Mac OS, this step is not required. However, for Windows user, you have to uninstall and reinstall numpy to prevent code errors. Type, you have to open to CMD and then type pip uninstall numpy. Proceed, yes or no? Yes. Successfully uninstalled numpy. You can check. Now go to https www.lfduci.edu. Type GOHLKE, then Python libs, then numpy, enter. From here, download numpy 1.14 5 plus MKL CP36 CP36M Win AMD 64 WHL. Click. This is the NumPy version compatible with Python 3.6 64-bit version. You can see NumPy installation is going on. Meanwhile, you can check Nvidia installer, where download is almost reaching 50%. Now question comes to your mind, why we are going to use PyTorch. Here our code can run on GPUs, which provides much faster training. When using a framework like PyTorch, you can harness the power of GPU for your own custom neural network architectures without having to write CUDA code directly, which is obviously very tedious. There are various other frameworks like TensorFlow, Keras, Theanos, but we'll be using PyTorch for this series since it is very much user friendly. Even debugging code in PyTorch is easier than other frameworks since it builds our network dynamically, that is on runtime, as opposed to other frameworks. We can compare PyTorch versus TensorFlow. While both TensorFlow and PyTorch are open source, they have been created by two different wizards. TensorFlow is based on Theano and has been developed by Google, whereas PyTorch is based on Torch and has been developed by Facebook. The most important difference between the two is the way these frameworks define the computational graphs. While TensorFlow creates a static graph, PyTorch believes in a dynamic graph. That means in TensorFlow, you first have to define the entire computation graph, which is nothing but the network of our CNN, and then run your ML model. But in PyTorch, you can define and manipulate your graph on the go. This is particularly helpful while using variable length inputs in the RNNs. TensorFlow has a more steep learning curve than PyTorch. PyTorch is more Pythonic and building ML models feels more intuitive. On the other hand, for using TensorFlow, you will have to learn a bit more about its working, and so it becomes a bit more difficult to learn TensorFlow than PyTorch. Now, which one is better? Actually, it's very difficult to say, as there is no right answer. Why is it so? The truth is, some people find it better to use PyTorch, while others find it better to use TensorFlow. Both are great frameworks with a huge community behind them and lots of support. They both get the job done. They both are amazing magical wands that will let you do some machine learning magics. I hope we are able to help you in clearing your confusions. Meanwhile, we can check how much download has been completed. 70% has been completed and will take few more minutes. Now a question comes to our mind: why do we use CNNs? In the meantime, let's discuss some applications of CNNs to real world scenarios. One is automatic colorization of black and white images. Image colorization is the problem of adding color to black and white photographs. Traditionally, this was done by hand with human effort because it is such a difficult task. Deep learning can be used to use the objects and their context within the photograph to color the image, much like a human operator might approach the problem. Let's see an example. Meanwhile, colorization of black and white images using CNNs. You can see the image from black and white, how it has been colorized using CNN. Another example of CNN is object classifications and detection in photographs. The task requires the classification of objects within a photograph as one of a set of previously known objects. State of the art results have been achieved on benchmark examples of this problem using a very large CNN. Results on the ImageNet classification problem called AlexNet. A more complex variation of this task called object detection involves specifically identifying one or more objects within the scene of the photograph and drawing a box around them. You can search for AlexNet architecture on your Google Chrome browser to read the paper. This is the paper reference on ImageNet classification with deep convolutional neural networks. As you can see in this paper, that their error was about 15.3%, which was a huge breakthrough in object detection problem using images. Our Nvidia toolkit is almost done. Let's see what will be done first, NumPy or CUDA toolkit, because both are close to get installed. Your screen may flicker while installation of Nvidia drivers is on. This is actually a normal behavior So don't worry, our NumPy installation is done. First, let's reinstall NumPy. Click to NumPy, check its properties and look for its location as highlighted. Then type pip install and copy paste the location. Then copy and paste and then press enter. Installing the packages with NumPy. While installation is in progress, let's again we can see that it has successfully installed NumPy version. So the question comes to our mind, what is the difference between tensor and NumPy array? Tensors are more generalized vectors. Thus, every tensor can be represented as a multi-dimensional array or vector, but not every vector can be represented as tensors. Hence, as NumPy arrays can easily be replaced with PyTorch tensor, but the reverse is not true. Actually, tensors provide a lot more functionality than NumPy arrays. In the next video, we will be implementing CNNs using CPU first and then GPU. We got this error because we already had installed this toolkit earlier. Your installation must have been finished by now. Thank you. All our installation are complete. Feel free to contact us for clarification. As with this installation, we'll move to our next video. That is, in the next video we'll see how to implement CNNs using PyTorch.